This presentation is about server technology basics. First, let's take a look at how a server works. A technician types things on a keyboard in front of a big, glowing rack of computers, lights, and wires. Then I can use the internet on my computer. Thanks for watching, everybody. We hope you learned a lot about servers in this presentation. Okay, so maybe it's not quite that simple. Let's start with the basic definition of a server. Mitchell, writing in 2018, defines it as a computer designed to process requests and deliver data to another computer over the internet or a local network. Technically, the term refers to the software handling these operations, but the term is often used to refer to the hardware running the software, such that the two packaged together are a server. Frequently, the computer running server software will be a dedicated server, engaged in only the task of serving. It is also possible to operate a server on a computer which is being used for other tasks. For example, when your son hosts a Minecraft server, his computer is simultaneously playing the game and acting as a server for others connecting. Other common types of servers include file servers, which are dedicated to storing files on a network for clients or the people using the network to access. Print servers, which predictably handle the duties of shuffling requests to printers and returning information about ink levels and so on. Database servers, like those that Sam Houston State University presumably uses, whether on-site or through a subscription service, to run its Agent Orange search engine and handle search queries. And web servers, which deliver web pages in response to requests such as typing in a URL. This here is a graphical representation of a web server handling access requests in real time. On the left side of that image, you can see the IP addresses making requests of the server. And on the right side, the little Pong-looking paddle is responding to those requests by serving the web page or whatever else the client is requesting. Clearly, it is important that these servers stay online 24 hours a day. This constant availability is one way in which they differ from a home computer, with corresponding differences in hardware requirements, including considerations for redundant power supplies. In this small server example, on the bottom right here, you can see a smart UPS, an uninterruptible power supply, which is a big battery that will kick on automatically in the case of a power outage and continue to power the server until power can be restored. In addition, because of their specialized role in the network, these servers are often headless or without any attached peripheral input or display devices. You think of the server farms that we've all seen before. Instead of using a keyboard and a monitor attached to the computer, the administrator can access the server for maintenance, etc., over a networked connection. When and how do we interact with servers in our daily lives? Let's take a look at some common examples. Netflix is an interesting case. They used to run their own servers, but made the decision some years ago to focus on other things and let someone else take care of the hardware side. They are now the top customer of AWS, Amazon Web Services, which provides the server functionality that runs Netflix processes. These processes include the microservices that comprise all of our interactions with Netflix, such as credit card billing, playing, pausing, and resuming shows, etc., hosting countless hours of video, and transcoding all that video into device-specific formats so that you can watch it on your iPad, your television, etc. In addition to these AWS-owned servers, Netflix uses its own Open Connect boxes. These are servers designed to ensure faster delivery of content to the user requesting it. The company delivers these servers to internet service providers around the country. When users on nearby devices request a show, the program queries the 10 closest Open Connect boxes with that content, or reaches out to the farther away AWS server if it is not available on a local Open Connect box. This starts to explain the longer initial loading time when you try to call up a less popular program, as well as the fast loading of shows that are likely popular with other users in your area. The popular programs are already hosted on an Open Connect box closer to your location, and Netflix doesn't have to reach all the way to a regional AWS server to download it. Google is probably one of the systems of servers with which we interact most frequently. I'll let Google describe it themselves in a short 1 minute 46-second video.
Whenever you use a Google product, you're connecting to one of our data centers around the world. Let's take a look inside and see how they work. Google employees work here, keeping the data center up and running 24 hours a day. The networking room is the first stop on our data center floor. The equipment here routes requests to the right servers in the next room. These computers also allow our data centers to communicate with one another globally. On the server floor, powerful computers handle everything from billions of searches to hosting YouTube videos and protecting your email against viruses. We've custom designed these servers to be compact and energy efficient. To ensure you have access to your data whenever you need it, we keep each piece of data stored on at least 2 servers. We store another copy of the most important data on digital tapes. When a hard drive breaks, we erase all of its content. Then, for extra security, we destroy it with our disk crusher. The machines in our data centers are always working. Cooling towers like these pipe in water to cool them down and keep them running. When the water heats up, we pump it back outside where it evaporates. Now that you've had a glimpse, walk inside yourself. Explore a Google data center with Street View.
What about servers for educational institutions? In an informative, detailed document about establishing a file server in primary schools, Rushton suggests that primary schools do not differ much in their requirements, other than in the number of users and computers, and, unlike with a business, this is usually a case where one design fits all. He goes on to recommend that the network designer consider essentially choose a small, medium, or large capacity server from their vendor in order to accommodate anticipated client load. This author's recommendation, a simple approach for a simple network dealing with only 1 or 2 types of clients and a predictable load, may differ from recommendations for establishing a network in a large post-secondary institution. In the 2018 version of their Campus LAN and Wireless LAN Design Guide, Cisco puts it succinctly when they write that there's a tendency to discount the network as just simple plumbing, to think that all you have to consider is the size and length of the pipes or the speeds and feeds of the links, and to dismiss the rest as unimportant. Just as the plumbing in a large stadium or high-rise has to be designed for scale, purpose, redundancy, protection from tampering, or denial of operation, and the capacity to handle peak loads, the network requires similar consideration. With regard specifically to servers, Cisco offers this helpful graphic. Presumably, considerations for choosing these base-level servers should be the same fundamental elements of anticipated load and security. In addition, Cisco recommends specific server functionality when it comes time to authenticate users by directing them to a server dedicated to credential checking, the Authentication, Authorization, and Accounting, or AAA server. This is another server type that I didn't introduce in the first part of this presentation. On the user side, this might resemble the SHSU login screen we hit when accessing any campus resource which requires account privileges. As a brief summary then, a server is a computer that processes requests and delivers data to other computers. It may be a dedicated server or one that is multitasking. We have different specific types of servers, about which I'm sure subsequent groups will go into more detail. And of course, we have many different interactions with servers in our daily lives.